Hello, chemistry. Today, I'm going to talk about infamous nuclear accidents. I used to call this famous nuclear accidents, but I don't know that you want to call them famous. Not quite like a movie star or a theme park, more like, wow, that's kind of bad. So we'll go through these. There is a notes file in the shared Google Drive that you'll want to enter some information into. What I'd maybe suggest doing if you haven't done it already, because I think I put it in the assignment, is to read through the notes file and kind of see what you're looking for. In general, you're looking for the significance of the different events, when they happened, and in the end, down the road, we're going to talk about peaceful uses of nuclear power or nuclear changes, and then kind of tie this all together into the question of, is nuclear science really a good thing or not, or does it depend? So let's roll through these. Starting back with, first off, kind of learning about nuclear criticality. Nuclear criticality is basically the point at which unstable isotopes get so close together that as, hold on, I'm checking my pen here. There we go. So if you have one unstable isotope and it breaks apart, it's going to shoot out uh, particles of radiation. And if you have other unstable isotopes, those particles of radiation are going to collide into those, and they're going to separate. And as this process multiplies over time, we call a chain reaction. Eventually, everything spirals out of control, and this part we're talking about here happens in fractions of a second. And uncontrolled, you end up with a weapon. So we see it down here. I got to change my pen color. You see it down here. If you have material that you let reach critical mass, and so critical mass is the minimum density of material required to allow one particle decay to trigger another. So if you're not at critical mass, and as one particle decays, the other particles coming out are not going to be able to trigger subsequent decays. But if you purify or compress the material enough, then one decay can trigger another, and you have a nuclear chain reaction. So if it's uncontrolled, as we looked at in the Manhattan Project, you have the core, like was in Fat Man or in Little Boy, that is subcritical. So it's just below the density needed to trigger a chain reaction. You detonate it, and through reflecting of the energy of that detonation, it squeezes the subcritical mass to reach criticality, and then boom, mushroom cloud, bomb goes off. If, however, you can control that reaction, you can allow that chain reaction kind of to go at a steady pace instead of multiplying and exponentially increasing. And we do that through features called control rods. And so you can see the control rods in this diagram of a research reactor. Just about every large research university has their own little nuclear reactor. MIT and Harvard both do, I believe. As you drive on the pike in the vicinity of Fenway Park, you're not that far away from a nuclear reactor inside one of the university buildings over there. But as you insert the control rods into the reactor, the control rods absorb those particles that are coming out of the nuclear decay. So they kind of reduce the ability of that particle to fly out and trigger another decay. So if you remove the control rods, as you pull them out, then less of those particles, usually neutrons, less of those particles are being absorbed, and the reaction speeds up. Keep in mind, one of the fundamental rules of nuclear reactors is never remove all your control rods. Keep that in mind. Never remove all your control rods. This picture of a research reactor is pretty cool. The blue light that you see is actually coming from the water. So you can kind of envision the particles of radiation, and I guess I'll draw them in red just because the radiation. There we go. So the particles are coming out of the radioactive material. As the radioactive material decays, it spits out radiation. That radiation is colliding with the water molecules that are surrounding it here. The water not only cools the reactor, but it also shields the surrounding facility from much of the radiation. But as the water absorbs that radiation, it does all sorts of really interesting things with the molecular structure and the electrons. Anytime you get electrons in motion, you can produce light. But I think that's a really great picture. Let me erase my little annotations here. Yeah, all right. So never remove all your control rods. So starting with what's kind of known as the first nuclear accident, the Demon Core. So we talked about how the core of the Fat Man bomb was, you know, not that much bigger than the size of a softball or a volleyball. And there was a third core. So we had Trinity was one, Nagasaki was two, and there was a third core that was not used because ultimately Japan surrendered and we didn't need to use it. So that core became kind of a tool for research. And scientists were kind of playing around with it to see what they could do to affect criticality. And one of the tests that they did was by using, yeah, I got to change colors again. Hold on, can't see that. Was by using something that resembled a salad bowl as a reflector to try and reflect the neutrons, reflect the radiation back into the core. And as long as you kept a screwdriver under the edge of it and didn't let it close completely, it wouldn't go critical. Well, guess what happened? Somebody bumped the screwdriver came out, and for a moment, the reactor went critical. And so there was supposedly this big flash of light that came out of it. There are a few people in the room. And what ended up happening is those people in the room were momentarily exposed to acute high doses of radiation. 2 of them died. 4 of them suffered serious injuries in what was described as a 3D sunburn. So basically getting a sunburn, instead of just being on your skin, it was throughout your entire body as the radiation emitted from the momentarily critical nuclear core flashed out into the lab. So that was really bad. The core actually had a second similar problem where it momentarily went critical. And because of that reputation that got of anybody who works with this ends up dying, they decided that they were going to nickname it the Demon Core, that it was possessed, and they ended up taking the uranium out, or that was plutonium. They took the plutonium out, broke it apart, melted it down, put it other places, and the Demon Core was destroyed. Out of this, however, if you look at this picture, this still amazes me. If you look at what the person is wearing, working with it, kind of looks like they're in school uniform, khakis and a sweater. We learned that safety really needed to be stepped up in working with nuclear projects. So this is when we started designing things like radiation suits and various types of ways to isolate the equipment where you weren't directly in contact with it, shielding in case of radiation. The Demon Core resulted in kind of the origination of the nuclear safety business, of realizing that this was not something just to play around with. Next accident was up in Hanford, Washington, which was the general area. It's this huge expanse of land up in Washington state where the plutonium was made for the Fat Man and Trinity bombs. The SO1 reactor was a research reactor up there. And, it was an early reactor. And so to move the control rods in and out, hey, I didn't mean to zoom. There we go. Went to draw. So lefties to move the control rods in and out, you basically stood over the reactor. By the way, I can't draw. And you would actually physically pull the control rod in and out of the reactor. And so one day, while um, working on the reactor, one of the control rods became stuck. So the operator stood over the reactor, grabbed the control rod, yanked it as hard as he could, and the control rod popped out of the reactor. And what was our rule? Never remove your control rods all the way. So the control rod came out, the activity in the reactor spiked, the radiation came out, interacted rapidly with the cooling water. The cooling water flashed to steam. The control rod became a projectile and actually impaled the worker to the roof of the reactor building. There was an explosion. The core overheated and melted. You get this term meltdown. And the idea there is that the reactor melts, the molten material being very dense sinks down. There was a movie that came. It's actually a fairly well-received movie, but it was called The China Syndrome, because there was this view that if you had your nuclear reactor that melted down, it would melt all the way through the earth, and the geographically incorrect saying of melting all the way to China. Um, if you actually go through the earth from Boston, you end up somewhere in the Indian Ocean, but that's beside the point. But the idea that the reactor melts down, and it is going to melt through concrete and just about anything else once you get radioactive uranium or plutonium going out of control. So this explosion killed 3 people. They ended up just taking the reactor and burying it in the desert out there, because really we don't have very good techniques for cleaning things up. And we see that in the next accident, 3 Mile Island in 1979. This is in Harrisburg, Pennsylvania, and they were conducting a test of backup systems. Now, one thing with nuclear power plants is they need power in order to operate, which is weird because we use these nuclear reactors to generate electricity, but they have to have electricity in order to function. They need electricity to run the pumps. They need their electronic control systems. So all of those need to be operational. So nuclear power plants receive power from the good old electrical grid. Don't want that. And they have backup systems, usually diesel power generators that power the backup systems. And backup systems, you always test them periodically. And during one of these backup system tests at 3 Mile Island, there were some cooling and water valves malfunctioned, and they were left set improperly afterwards. And through then some human error, the crew misinterpreted temperature in the reactor. They misinterpreted some readings on coolant flow measurements, and the reactor overheated. As the radiation interacted with the water, it produced hydrogen gas. That hydrogen gas was safely vented. There's no documented injuries, so there was a little bit of a radiation release, but the studies have shown to have been so small that it didn't cause any effects. And even though this is before Chernobyl, which you've probably heard about, this was actually a more advanced reactor design. So some of the safety systems worked. There was no explosion, there were no injuries, but it was publicly reported as to what happened. It greatly undermined public faith in nuclear power. It happened almost right at the same time that the movie The China Syndrome, which was about a fictional nuclear accident, came out. And there were all sorts of protests against nuclear power. And really ever since then, the United States has had very little interest in building new nuclear power plants. So here's a picture of 3 Mile Island. Very recently, they're actually in the process now. They're going to shut down the entire plant. But since 1979, there were 2 reactors on the site. The one that melted down was shut down, never repaired. it still has not been fully decommissioned because the material inside is so radioactive. It's still going to be a number of years before it decays to the point where they can safely get inside to finish tearing it apart. So the reactor next door has still been operating. And so if I've flown over 3 Mile Island a couple of times, and you can see the steam coming out of the cooling towers from one of the reactors, and then the other ones just sit quietly because that reactor kind of ate itself back in 1979. The thing with 3 Mile Island, Chernobyl, which we're going to look at next, is the largest accident ever. And if we take a major accident like Chernobyl and we say, well, what if 3 Mile Island had done that? This is a map basically showing the potential casualties in the area around 3 Mile Island. And, long story short, pretty much everybody in this area, yeah, you could pretty much figure those people would likely not survive the radiation dosage depending on the wind direction. So that includes, locations like Philadelphia and Washington, D.C. and State College, Pennsylvania, not the Nittany Lions. Serious health risks depending on wind direction in the next ring out. So, out in this area, you've got New York and Atlantic City, New Jersey, Pittsburgh. We've got quite a population here that potentially would experience significant health effects. And really, the inner circle here is going to be rendered uninhabitable for decades because of radiation. That's a big wow. It's a big what if with nuclear accidents. None of the ones we've seen so far have affected any significant area. But, this map, this discussion that I'm showing you right here is why after 1979, a lot of people in the United States felt that they did not want nuclear power. Sad, because nuclear power plants are very clean. You can drive up to a nuclear power plant and not really even know it's there. There's no carbon dioxide emissions. There's no greenhouse gases. There's no, you don't have to have smoke coming out and those sorts of things. But, there are issues. You have to mine the radioactive fuel out of the ground. The radioactive fuel has to be, treated properly when it's in the reactor. And then when it's done, you still have leftover radioactive materials that we really don't know how to dispose of them. So, we look at Chernobyl. That's not what I want. We look at Chernobyl. Here we go. Another case of a planned test of backup systems, working with backup systems. And during the test of their backup power, the power actually went out. So the actual power failure caused the test to be halted in the middle. The test was passed off to the inexperienced night shift, who usually their job was simply to, make sure nothing bad happened. But now the day crew said, hey, night shift, go ahead and finish the test. And so they didn't realize that this 100-step procedure had been stopped on 50 and they needed to restart from that point. No, they went back and they started on step 1. And that kind of got, valves and switches and things in the wrong places, and it created a bubble of xenon gas in the reactor. And xenon is one of those noble gases that doesn't like to really do anything. So the bubble of xenon acted like a control rod. It slowed down the reaction. And the workers saw that, and they're like, well, gee, the reactor's not producing enough power. We need more power. So they removed the control rods. Don't remove your control rods. So they removed the control rods, finished the test. After the testing was done, the xenon bubble kind of went away, and then you had a reactor that was in an uncontrolled state. Hydrogen produced, the hydrogen exploded, the reactor lacked much of a containment structure, and boom, the reactor explodes. The multi-thousand ton lid of the reactor was thrown 100 feet up in the air, and it was an amazing explosion. And so this was the reactor. It's now a big hole in the ground. And flying over this, what you have to realize is that this is spewing radiation out of this hole. I mean, the people taking these pictures in the helicopter being exposed to lethal doses of radiation. Many of the first responders to Chernobyl died in the process of trying to respond to it. The core melted. This was they able some people kind of sacrificed themselves to get in and get pictures to try and figure out where the radioactive fuel had gone. And you can see this ooze coming out that is molten fuel and other parts of the reactor flowing down out of the bottom of the reactor vessel. And so the result of this was thousands of immediate deaths, tens or hundreds of thousands of long-term deaths. Entire cities and hundreds of square miles were rendered uninhabitable. If you look at the scale on this map, it's a little hard to see, but this is 100 miles here on the scale at the bottom. And so pretty much the areas in red and dark pink on this map are pretty much permanently uninhabitable, at least in terms of any of our lifetimes. The radiation levels are so high in that area that nobody will ever be able to live there again. So these are areas that are 100 miles long, 50 wide. We're talking state of Massachusetts size, rendered completely uninhabitable in the kind of Ukraine-Russia border region. There was a town nearby, a city called Pripyat. You can actually see the reactor itself off in the distance if you look in the haze there. But this was fully occupied the day the accident occurred. And initially, none of the residents were told what was going on. And there was an amusement park scheduled to open in Pripyat, and the Soviet government ordered that the amusement park be opened a day earlier than it was scheduled, so that the residents would be distracted by the amusement park and wouldn't pay attention to what was going on at the nuclear power plant off in the distance. The West, Europe and the American allies during the Cold War, didn't know about it until some nuclear power plants of our allies in Northern Europe started having their radiation alarms sound. So you can imagine you're at a nuclear power plant in Sweden and your radiation alarms going off, you're going to panic. You're going to say, whoa, are we leaking or something? And then what they figured out is it wasn't them, it was somebody else. And only then did the Soviets actually admit that they had had a small little incident at their nuclear power plant, which turned out to be the largest disaster in history. So the town was rapidly evacuated. Tours through it have found, books still on students' desks in their schools. It's this really kind of weird ghost town. And so, like we've said before, you just don't know how to clean any of this up. And so, with the inability to clean up the reactor, the solution was to build a cover over top of it. And that cover is shown right here. It's called the sarcophagus. It was a quickly assembled cover, not overly well built. All of the equipment used to build it is still on site because it's so radioactive that it can never be decontaminated. A lot of people working on it died of radiation sicknesses and cancers. And over time, it started to leak water. It started to rust. It was falling apart, and there was a real risk that the structure was going to collapse, and when it did, it would blow up a cloud of radioactive dust, and it would make the whole problem even worse. So there was determined to be no way to tear down the sarcophagus, so the solution was, let's build another one. And so another containment structure was built, and it was built on rails so that when it was finished, they would actually roll the structure over top of the original sarcophagus to cover it up. And so that structure is believed to be able to last about 100 years. We still will not be able to clean up Chernobyl unless there's some magical new technology that comes out. So in 100 years, the probability is that we will have to build a new containment structure to go over the old containment structure that is now over the original containment structure. And if that doesn't just make you shake your head, I don't know what does. So Chernobyl, largest disaster in history, followed second by Fukushima, Japan, 2011. Fukushima is a prefecture. Think of it like a county or a state in Japan. And there was an oceanside nuclear power plant with 6 reactors, different designs and fuel types. They were built in different times, and a magnitude 9 earthquake. And a magnitude 9 earthquake, this was one of the top 10 earthquakes ever observed in recorded history. Produced a tsunami. So the earthquake was under the ocean. The ocean floor lifts up, it moves the water and produces a giant surge of water that pushes on shore. That tsunami destroyed the primary and backup power systems. The reactors overheated. Again, the radiation interacting with the water produces hydrogen that ignites. You had 3 core meltdowns. You had explosions of unused fuel that was being stored there. And so all sorts of problems. So here's a picture of the plant, power plant before the tsunami, and I believe these are, if I have my numbering right, 1, 2, 3, 4, 5, 6. Reactors 5 and 6 were not in operation. 1, 2, 3, and 4 were in various stages of operation or refueling. And so the tsunami wave washes on shore and takes out all of the backup power systems, which were located right along the coast, takes out the primary power system. So basically you had no way to control cool the reactors, and they started to explode. So there you see one. Here you see a kind of a 4-frame shot from a video showing the hydrogen igniting that was being produced under pressure from the reactor, and that blows the top off of the reactor. You can see here the results after the reactor building exploded. A lot of these first responders went in believing that they were essentially on a suicide mission, that they were sacrificing their lives to try and get in and put in these pump trucks to try and spray water down on the reactor to prevent it from getting any more damage. And truth be told, a lot of the modern safety equipment, though, there have not been a very high number of casualties reported as a result of this. It'd be hard to tell long term as far as cancers or things like that, but there have been notably few direct injuries as a result of the malfunctions of the power plant. And this should look familiar. Don't really know how to clean it up, so they're beginning to build containment structures to put over top of the reactors to seal them up for time. That's kind of, from 1986 to 2011, that's still the best we can do, is cover it up and hope somebody later figures out what to do with it. Interesting, there was a whole new field of designing radiation-proof robots to be able to go inside and see what actually happened. Radiation proof is kind of taken lightly because every robot that they have put into the reactor buildings to take pictures has been destroyed by the radiation in the process, but they have been able to get inside and see it. And you can see kind of here this hole in the reactor area where the fuel melted and has been melting or had melted down through the structure inside the reactor building. So before you can clean something up, you kind of have to know what the extent of the damage is. And so these images are an attempt to figure that out. So the effects, a lot of local land contamination, extensive water and ocean contamination. There was radiation detected from this in ocean waters off the west coast of the United States. No direct deaths, some injuries. Don't know about the long-term effects. You can see here some of the structures being built. All of these so that they pump the water in to try and keep these things cool and prevent them from melting even further. And all of that water is contaminated. And again, radiation is not something you just clean up. So they've been storing a lot of the water on site and just progressively building more and more and more and more of these storage tank farms to try and capture the water until the time that they can figure out what to do with it. And that idea of nuclear waste, spent nuclear fuel, cleanup water, all of that, that's kind of permanently contaminated, or at least contaminated until the material decays enough to be safe, that's a real problem. So in summary, nuclear accidents are rare. While there have been several accidents, only 2 have affected more than the plant itself. That would be Chernobyl and Fukushima. The severity of a single potential accident is far worse than even a worst case scenario for other forms of power generation. So, if a wind turbine fails, it's not going to contaminate the entire state. Even a massive fire at a coal burning power plant is not going to have quite the long-term effects. But the accidents don't happen that often. So there's this kind of paradox here with the accidents. The accidents can be really bad, but they don't happen that often. And can we build a nuclear power plant that is essentially fail-safe, meaning that, if they lose power, if all these other things happen, can they shut themselves down and with all reasonable certainty prevent an accident? And there's a company named Westinghouse, used to actually have facilities in Hyde Park, over near the lacrosse field. They are working on designing the ultimate safe shutting down reactor design, and we'll see if that ever comes to fruition enough that the American public will accept their construction in the United States. So whether or not normal operation safety, so meaning apart from accidents, whether or not normal operation safety of nuclear power to other forms is inconclusive. No greenhouse gases, no large impact on the surrounding area. They just kind of look like, large office buildings or things, but the fuel, getting it and what to do with it when it's used up, it's still radioactive, and the potential of an accident, really, there's no clear answer on whether nuclear power is a good thing or not. All right, so that is our overview of some of the more significant nuclear reaccidents. Not a lot of them, but some amazing stories with all of them.